going live now. What's up, AP Stats? This is try number 2 here. Apologize for that. I was trying to figure out some logistics on sending out different things, and that's completely my fault. But we're back at it here, and we're going to go ahead and get this rolling again, and I'm going to come back. Let me see where I'm at. All right, here we are. So what I was talking about within the previous podcast, and hope this takes here. Let me make sure before I get started. Yes, okay, should be good. If it's not, please let me know. Shoot me something, shoot me an email, text, or whatever. But we're trying to figure out basically the windows of this box, and it says we're conducting an experiment to compare the heat gain in houses using 2 different types of windows, both A and B. 6 windows of each type are available for the experiment. And so the department has constructed a house with 12 windows as shown from the floor plan. So the interior of the house, each window is surrounded by a window box to capture the measure of the heat coming in through the window and isolate the heat gain for each window. Now, a couple things you need to note on this that may not actually be in this part, and I apologize. I'm hopefully right on this a little bit better. So the big thing to remember is that blocks are the same. So when we remember this, we think of this as homogeneous, meaning they're the same here. The observational part of blocks would actually be a stratified, but this isn't an observational, this is an experimental. So because of that, we're going to move into blocks here, okay? So the question is what are the homogeneous blocks? So we know that if the sun was shining down on a specific area, each side of the house would get similar exposure to the sun. So probably the best thing to do would be to block this based upon the exposure to the sun, where each side would be a separate block because those would be the same. So we would say box 1 and 12. Another one would be box 2, 3, 4, and 5. Another one would be box 7 and 6. And then finally our 4th block would be box 11, 10, 9, and 8. And if you were to give it a reason, we would say, what does it say? Justify your block. How would you group them? Okay. And just say something, say due to the light of the sun exposing itself differently on each side of the house, we would expect each side to, I guess, measure similarly concerning, I just need context. To measure similarly to heat without or with similar windows. You could say something like it's homogeneous, which just means it's the same, and therefore we can randomly assign from these blocks as a result, okay? All right, so that's part 1. Hopefully you got that one part down. Blocking is just we want to make sure it's the same. The next part asks this. It asks, for the design of part A, describe how you would assign windows to the numbered window boxes. Well, here's the thing. So we've got, if we have this, we have 12, right? So we go into 4 different areas, right? Side 1, side 2, side 3, side 4, okay? So how much do we have? 6 windows of each type are available for the experiment. Okay, so we've got each can get a window. So this is all blocked, right? So we would say this. Let's just start by doing this. We say we would start by blocking. And by the way, I would pause this and maybe try this one out and see if you can actually get these things down. So we would start by blocking the windows based on the side of the house based on the side of the house, into 4 blocks. Okay? All right, we got that part. So block 1, 2, 3, 4, side of the house. We then randomly assign the windows in each block from 1 to 4 or 1 to 2, depending on the side of the house, right? Depending on the side of the house. We got to talk about how we randomly assign, right? So we could say we put the number of window in each block on a piece of paper and select. So we have to select so if there's 4, you have to select 2 of them, right? And select either 2 of 4 or 1 of 2. And those will receive window A. All right, you with me so far? All right, so get that down. All right, we're coming back here. So right now, here's where we're at, okay? Coming back. So right now, we've done pretty much, hopefully that comes back here. There we are. So right now, we've had 12. We've blocked into 4. Then we randomly assign into each, right? So these are blocked. This is a block here. Randomly assign, randomly assign. And when we do that, we go into 2 separate things here. This is window A, window B. And then so the rest of them, we have to say the rest of them of the windows not chosen receive window B. Okay, see how, again, we got to make sure that we're very thorough on this, okay? Then, over a period of time, so we grouped them together, right? And then after we grouped them together from our random assignment, we've given treatment A, treatment B. Then over a period of time, we compare the heat within each block. Okay? Perfect. And that's how we would go and attack this, okay? Again, that's very, very thorough. But the biggest thing is anytime that we look at this, the toughest thing is to remember, okay, how in the world do we approach this, and how do we see something that's similar? And absolutely, we can kind of look at that and go after that and see it. KD, I got you, man. Nice job. Thanks for showing up. So yeah, we can absolutely do that on there. So very, very important. Tomorrow, I think it's something, I don't know if it's an experiment or if it's a stratified random sample or how we work that, but it's very important that you figure out and try to analyze these FRQs. One is like writing about which sample would be the best and why, and really going diving deep into that. Writing about that, just be very, very thorough, okay? Providing evidence over that there, okay? Good stuff. Let's see here. Going into this, okay, so questions. Katie, I got his question, and I don't want to ignore that. I think MB had one, number 23. Let's go over that. Let's go over 23, and then I'll go over if y'all. Okay, number 23. We're gonna go over these specific questions. Let's see here. Let's see. Okay. Perfect. Okay, I think you can see both those there. Okay. So here's the opening of a press from June 2004. Starbucks Corporation on Monday said it would roll out a line of blended coffee drinks and intended to tap into the growing popularity of reduced calorie and reduced fat menu choices for Americans. You wonder if Starbucks customers like the new Mocha Frappuccino Light. I love those. As well as the regular version of this coffee. Okay, so describe a completely randomized design using 40 Starbucks customers that would help answer this question. Be sure to discuss blinding. Okay, so if I was to do this, right? So, completely randomized design. Okay. First of all, we would have to get 40 random customers, right? In order to infer to the whole. I'm trying to think of. Anyway, we're going to assume this, that the 40, I would just say something like this because you could talk about this all day. We're going to make sure that this is a random sample of Americans, right? Because in order to infer to all of America, we have to have 40 people that go to Starbucks consistently at random, okay? So then, do they like it? Okay, as well as the regular version. You wonder if Starbucks customers like the new one as well as the regular version of this coffee. This is really a weird one because I don't know if it said it would roll out a line. I would say, MB, this is a tough one. You wonder if they like the new one as well as the regular version of this coffee? Man, I would say that's really weird, the fact that it's and. I would say or, maybe. Because if you're really doing an experiment, if we were completely randomized, we're going to have a random assignment, right, into two groups. One size group of 20. Group 2 has 22. This has treatment 1, treatment 2. Treatment 1 will be the regular, and treatment 2 would be the new. And we'll basically compare the, after treatment 1 and treatment 2, we give them a survey over, after they drink it, we compare survey results afterwards, okay? That's what I would say completely randomized design would be. Obviously, yeah, and then discussing blinding would be, we're not telling them which one we're giving them. So they don't know which treatment, whether it's the new one or whether it's the old one, that's there. That's what I would say on this one. And then says, a friend of yours in AP Statistics says no, that adults and teenagers have different tastes and suggests that a better way to design an experiment is to use a block design. Describe that. So I would just go into, instead of, we don't know how many teenagers are over here, but we would just say before random assignment, we would then go into teenagers versus adults. And then you would go into, each would have a random assignment. It would then have like two separate experimental groups, right? So the teenagers would be blocked and so would the adults there, okay? All right. Then says, but later in the day, a stats teacher poked you and said that he thought a matched pairs design was the best method. How would you design this experiment? Oh yeah, I would say this. I would say, based on those 40, you would rank them somehow. So how would I rank them? I would rank them based on money spent at Starbucks. Or you could have done money spent on that specific drink, and that's fine. And you would just rank them 1 through 40. ... all the way to 40. You would match up the first two, second two, third two. You'd flip a coin. You're gonna have to explain this, right? Flip a coin. Heads would represent person 1. Tails would be person 2. And then you would just say, if I do heads, if you're the one chosen, those would go in a group and they would receive treatment 1. And if you got tails, then if whoever didn't get selected would go and do treatment 2. Okay, so that's matched pairs, but you have to rank them, right? It's all about ranking with matched pairs, and it's matched pairs is size 2, right? Size 2 blocks after ranking. Okay, very important. Again, that's the homogeneous thing, is that you're with someone that is similar there. Okay, good question, Katie. I'm coming to yours, man. That's a good question on yours, MB. Let's go to yours, KD. Okay, 15. Okay, which of the following are important in the design of an experiment? These ones always trip me up because they all sound right. Control of confounding variables. What's up, babe? How are you? That is my wife right now getting water. Just in case you're wondering. This is really awkward right now.
I'm done.
Do you need to get ice too?
No.
Oh, good, because that would have probably been even more distracting. Number 15. Which are important in the design of the experiment? Well, control of confounding variables. Yeah, that's check 1. That's important. Number 2, randomization and assigning subjects to different treatments. Yeah, that's very important. Number 2 is very important. Number 3, replication of the experiment using sufficient number of subjects. Yeah, I think that's good too. I think it would be all 3, y'all. I think it would be. If it's not, tell me, because that almost seems like all 3 are correct. Did it give you a different answer? If it did, yeah, give me a shout out or something. Just be like, Coach, give us a different answer, and we can look at it there. Let me see here. Let's see what we got. Cool. By the way, I'm trying to see here. Let's see. See on this. I'm gonna make this larger. Sorry about that. You're seeing all where the magic happens over here. Oh, good. Perfect. Okay. Nicely done. E's here, KD's here, Metro PCS, hopping. Love it. I'm getting all of these over here on this side, y'all. Keep it up. Any other questions y'all have? Do y'all have any specific things? Did I have this? I wanted to show you all this part. Seeing if this will come up. Remember to look at also when you're going through the topics page, look at the concept list. It's very important. It's a big deal, especially on these tests, especially when you're studying, noting these different things. So if you scroll down to the bottom, all of these things are important, like designing a simulation, table of random digits, observational versus experimental. Some of these are review, like percentile to Q1 and Q3. These things are not here by accident, so please make sure you look at this. This number 16 is huge. Choosing the best method. So I think it gives you like 2 different things based on your knowledge about what would be the best option. Noting 16 is huge. Write about it. Be thorough, be clear. Don't ramble, but be clear on what you expect. And then also know how to conduct a cluster. This is the FRQ and this is the FRQ up here. So like remember with a cluster, let's look at that, okay? It's another really good one. Let's look at this one. Okay. Let's come back to our stuff over here. Where you at, Coach? No, not that one. Getting it here. Let me see. Is it this one? It's just this, right? Okay. Okay. Yeah, we're here. Okay, so what I was trying to do is like with a cluster is if I was to trying to think of another example. So if I was to go about this with a cluster sample, remember the observational study and all of that, like that's very important, right? So when we think of something where we're going after an observational study and we're trying to figure out, okay, how can we perform a cluster? It's important to remember that it's very, very specific. So let's say that I'm trying to find a cluster. I'm using a cluster sample. And the question at hand is, let's say, our study at home, okay? Now, here's the thing. The problem with this is we have to think about, does the cluster represent, is this a mini cloud that represents a big cloud, that when we pick one of these mini clouds, right, and we'll pick a couple of them, when we pick it, does this thing fully represent the population? Now, the key of this is we got to be careful, because when we look at a big cloud, an SRS is something that is one mini cloud that represents the big cloud. A cluster is different. If I was doing hours studied at home and I was looking at just Hebron, but I didn't want to sample all the students, the population would be hours studied, right? We know that. At home for Hebron, right? All of Hebron. But we remember that in this instance, we can't just, SRS we could just pick 100 students, but at the same time, those 100 students could all be seniors, they could all be kindergartners, we don't know. So we want to make sure we come in with this cluster sample, and I'll use this in green. So what is a cluster? A cluster is something that is a mini cloud, not an SRS, but it has everyone in it. So you say, Coach, how could I do that? Well, think of this. If I were to put all of Hebron that were in the gym, and I said, okay, let's divide this up between, I want to go kindergarten through 12th with each of these. But let's say over here we have last name from A to D. And E to H would be over here. And I to L would be over here. M to P. Q to T. And then so on and so forth. And then I said, okay, let's number all of these clouds. 1, 2, 3, 4, 5, 6, 7. I then would randomly choose one of these clouds, or two of these clouds, let's say, and we get the numbers. Let's say we get the numbers 2 and 7. Everyone in that group will actually be sampled and therefore form what we call our cluster. Now, why is this important to remember? Because the cluster, each cluster has to represent all aspects of my population. So what I couldn't do is put kindergartners first, second, third, fourth, fifth, sixth, all the way through, and then randomly select 3 classes and then sample everyone. Because what if it was like second, fourth, and fifth? That's going to be a lot different than junior or sophomore year. So it's important that everyone within these mini clouds, or every mini cloud, is representative of the big cloud. Okay? It's different than an SRS is where I number everyone off and I just randomly select an X number of people. Okay? But it's very important that you remember that, and remember that for tomorrow, specifically on the FRQ. I believe both FRQs are going to end up being more of an observational side than an experimental side. Okay? Oh, okay, you're talking about the list. I'm sorry, Katie. 15 on the list. Let me see what I got here. Impact of an outlier on R, R squared, y-intercept, and slope. Good one. Okay, so if I have, let's say, an LSRL, right? So we have our explanatory, we have our response. Let's say this thing's fairly good here, where, has the dots and so on and so forth, okay? So let's say we have our LSRL, and let's say it's y hat equals 2.89x plus 3.4, okay? Let's say R is about 0.6, and R squared is 0.36, okay? All right, so we got this, this, let me see if I have anything else. Y-intercept slope. Okay. All right. So as we look at this, let's say that I ended up putting an outlier up here. Okay. Now, if I added in an outlier, okay, or maybe it would be better if I took it away. Well, but you could kind of work backwards on this. If I had an outlier up here, right, and I were to take this outlier away, this thing would level off more, wouldn't it? Like if this was taken off, this thing would push this down. Because why? Because this already pushed the green towards it, right? Now, since I take it off, we could expect this to go this way. So what would happen? Well, the slope would decrease. The y-intercept would actually increase. The r would actually strengthen, right? And therefore, the r squared will also increase. When I say strengthen, it would get closer to 1, right? Because it's positive. And so because of that, we could assume that that would be the response of an outlier that's there. All I need you to do is just remember that an outlier does in fact have impact on those, and just be able to see that and impact, and see how this, if I added this, it would do the opposite, right? It would weaken r, it would decrease r squared, and therefore decrease y-intercept and increase the slope that's there. So just know the difference as I either take it away or add that in. Okay. Good question. Alrighty. Any other questions out there? Let's see here. Trying to see here if there's any other questions on this. See if there's anything else here. What does a block do? It decreases variability because it focuses on things that are in common, right? Good. Gotcha. I'm looking at all this. Stratified, remember, that would be, like for illustration, would be where we divide it up between kindergarten and 12th graders and then take an SRS from each grade. Okay. Remember bias, make sure we check out those notes too. Make sure you understand that. Designing a simulation is very similar to what you would do just in terms of randomizing there. So be sure of that. Stem plot, know how to use SOCS, right? Shape, outlier, center spread. Trying to see if anything else. Do y'all have any other questions at all? Kind of wait and see here. I'll do this last one here, which kind of could talk over if we need to. Let's see here. So try to get this up. All right, response variable, identify the treatment, experimental units. Trying to see if we can actually get a, no, not that one. Let me see here. These are FRQs. Just taking a look here. Might be good just to look at 21. Just a heads up. That might be a good one. Number 20. Yeah, I'm looking here just at a couple of them. Just a couple different ones. Yeah, this is a good one, like one right here. Yeah, this is good. Yeah, I'm looking at any other questions y'all may have. Experimental units. Yeah, good question, Alyssa. Sorry about that. I know I went silent there. I'm just waiting on y'all. Yeah, so when we look at experimental units are simply the people that are getting the experiment, or the things that are... I don't know why this isn't letting me go. Let's see here. There we are. So if I were to start with, let's say, 20 people, and I was to randomly assign into two different groups, the actual 20 people is what we call subjects. And the reason why we call them subjects is because they're actually people, but they're also experimental units. So it's kind of the same word. But if I were to use like 30 lab rats, then we call those experimental units EUs, not subjects, because they're not people. So basically, that they're the thing that we're using to determine the, after we randomly assign them to groups, they're what we're using to compare the cause and effect relationship with our experiment. Does that make sense? Hope that makes sense there. So that's kind of what we're doing on that. By the way, my phone just died, so if y'all want to try to message me in that group thing on there, that's perfect. So if you want to put that on there, no problem whatsoever. I'm going to come in, see if y'all have any other questions there. If you could re-put them up there, if you have it, just put it on that live chat on that side while my phone's coming up here, and I'll double check that here in a second, okay? Cool. Good stuff. Any other questions y'all have for me? Cool, I'm gonna check my phone real fast. Yeah, so only one FRQ is due tomorrow, y'all. I'm not trying to kill y'all in terms of the amount, the load, and all that. So yeah, no worries on that. Okay. So yeah, just make sure. Yep, I got you, KD. Let's do 10 on the review. Let's see what we got there. Okay. It says to attain a sample of 25 students. Well, did I just throw off? Let me see here. On it. Am I still going? No. Am I still on? Hey, am I still on, y'all? Oh, I am. Okay. Wow, that was really weird. I accidentally hit the button, so hopefully... Oh, man. Oh, my goodness. Hold up, y'all. Y'all, I have a former student on this right now. Brianna, what is up? Brianna, oh, my goodness. Oh, my word. I can't believe it. Yes, we can go over match pairs for sure. Brianna, this is crazy. I just had like a moment. That's so cool. Oh yeah, so I am back. I'm sorry. So number 10 on the actual review. Let's roll with that. So it says to obtain a sample of 25 students from among the 500 students present in school one day, a surveyor decides to pick Every 20th student waiting in line to attend a required assembly in the gym. Explain why this procedure will not result in an SRS of the students present that day. Well, if it's every 20th student, could there be something similar between all 20, like the first 20th, the 20th student? Plus, like, are they in a specific group? Like, how are they situated? Doing it every 20th is not an SRS because it's not everyone is as likely to be selected. They could be, in different groups there. So then describe a procedure that will result in an SRS of the students present that day. Well, this is where you would number the students from 1 to 500. You'd put all their names in a hat. You randomly select 25 of them, and then take the sample or SRS from that, the 25 from that, okay? Cool. Brianna, I miss you so much too. This is so awesome and amazing to have you on this podcast. The fact that you graduated and are still a part of these podcasts. Brianna, what we should have done is just pretended like you were from Sweden, By the way, I forgot to say that at the beginning, y'all. So anybody from Sweden that's watching this, thank you for watching this. Y'all are amazing. But Brianna, you're even more amazing, for sure. So, gotta love it. All right, let's go over types of experiments. And, KD, I got you. Sweden students, there we are. Match pairs. Yeah, Remy, I kind of went through that. Did I hit that already, or did I miss that one? Match pairs, remember, is if we were trying to figure out the total hours of studying. Like if we were focused on the total hours of studying that was here, and we were to focus in on that, we would, we may not want to just do an SRS. Another option we could do is say, okay, let's go let's pair them up based on GPA. And let's rank them based on GPA. So 1, 2, 3, 4, all the way to, let's say, 170. So then what we could do is just pair the first 2, second 2. And so what it is match pairs is blocks of 2. And then what you would do is say we flip a coin. And after we flip a coin, heads tells me that the first one goes into treatment A. Treatment 1, and I'm sorry. Let's backtrack. This would be observational. I need an experiment. So total hours studying, let's say with a computer and without. Okay, so we're just going to compare that, right? And without, to see if that impacts the amount of studying. So treatment 1 would be with, and treatment 2 would be without. So if I rolled the heads, 1 would go here, and if I rolled the tails, then 1 would go here. And we would just make sure that we do that. Once we create treatments, you have equal groups to then assess and compare from those groups there, okay? Cool? Cool. Alrighty. I think someone said something about experiments, which was really, really good here. Yeah, KD, good question. Match pairs are basically block experiments, but the blocks are of size 2, not of whatever we are dividing, whether it's male or female. So it's blocks of size 2. 1 goes one way, 1 goes another. Good question. Yeah, you can do it from least to greatest or greatest to least, depending upon what you're doing. Just make sure that they're in order. So put them in order, however you put them in order. Yep, so it's basically ranking them and then going from there. So if we compare today the golfing outing, we could put Logan and Joe in the first group, and then I think it was like KD and myself in the second group, although I think Garrett was in there somewhere. So yeah, you would do that. All right. Oh, let's see, types of experiments. Okay, so the types of experiments are as follows. Let's see here. Actually do this. So there's a couple. There's randomized block design, and I think I got 10%. So we're gonna keep rolling, but if my computer dies, we'll be good. Okay, so we got randomized. That's the basic, like, randomized design. That's like where you have one random assignment, then it goes into groups, create groups, then goes to treatments, right? And then compare. Then you have the randomized block design. That's where you block based upon a similarity that you decide. So maybe here you could go male and female, and then you have a separate experiment of random assignment. So you almost got too many experiments, or how many ever you want. Like over here, we had 4 going on because we had 4 different blocks, which is appropriate. And then the last one's match pairs that we looked at. And that's where we pair them up based upon ranking. And we have blocks of size 2 that we approach there, okay? Good stuff. Y'all are coming in hot. Love it. Let me see if you have any other questions on my phone here. Good stuff. Any other questions y'all have for me? Cool beans. Mariana, you made my day today. Sweden students, you made my day today. Hebron students, yeah, you made my day today too. Today might have been one of the funnest lessons we've ever had. That was pretty cool. Brianna, you missed a good one. If you I have to message you or something about it. It was pretty cool. But anyway, y'all have a great night. Happy studying. Make sure, obviously, homework should already be done. Review shouldn't be too hard with the 1 FRQ and then the multiple choice. Make sure all that's turned in tomorrow. And y'all got this. Tear it up. Love y'all. And be blessed. We'll see y'all tomorrow. Bye.